So now I want to discuss a corollary that's going to allow us to do what's called modular arithmetic. That's addition and multiplication when we're working modulo. Okay, so the corollary states this: let m be a positive integer and let a and b be integers. Then a plus b mod m equals a mod m plus b mod m mod m. Okay, and ab mod m is equal to a mod m, b mod m, then modulo m after that. Okay, and we're going to have a special notation that we use, and it'll look something like this. For addition, it's going to be a plus m b. Okay, where m is your modulo. Okay, and then multiplication is going to look like a times mb. So a plus mb is going to be a plus b mod m, and a times mb is going to be a b mod m. So let's take a look at some examples in order to kind of show how this works. All right, so let's consider that we want to take 57 plus, and we'll do it mod 17, 88. Okay, so this is 57 plus 88 mod 17. All right, so the first thing that I want to do is I want to figure out what 57 and 88 are in mod 17. So 57 is going to equal 17 times 3 plus 6. Okay, and 88 is going to equal 17 times 5 plus 3. Okay, so 57 mod 17 is equal to 6, and 88 mod 17 is equal to 3. So what we'll do is we're just going to add those together. So 6 plus 3, and then we'll mod 17 them, okay, which is actually just equal to 9 mod 17, right? Or which is equal to 9 mod 17, which is equal to just 9. So our answer here is 9. Okay? What if we wanted to multiply the two of them? So we take 57 times 88, okay? And we want to figure out what that is, mod 17, right? And so that's going to equal, right? We're going to take their modulo, so 6 times 3. This is going to equal 6 times 3 mod 17. And that's equal to 18 mod 17. Now 18 equals 17 times 1 plus 1. And so that implies that 18 mod 17 is equal to 1. And so our answer here is 1. All right. So from a process perspective, what we're going to be doing is we're first going to be figuring out what the modulo is for each individual number, right? So in this case, 57 and 88. Okay, once we found those, if we're adding, we'll add them together, okay, and then figure out what that is modulo whatever modulo we're working with. Okay, so in this case, modulo 17. For multiplication, the process is the same. We'll figure out what each one is from a modulo. Okay, so like in this case, 6 and 3. And then we'll multiply those two together. So 6 times 3 is 18. And then I'm going to convert those using modulo into my final answer. Let's take a look at another example. And so suppose that what we want to do is we want to do 423 plus, and we're going to do this in modulo 7, 123. Okay, and you can imagine this might be a little bit tricky to do outside of our methods for modular arithmetic. All right, what we're going to do is first find what 423 mod 7 is and 123 mod 7 is. So 423 equals 60 equals 7 times 60 plus 3. Okay, so 423 mod 7 equals 3. And then 123 is going to equal 7 times 17 plus 4. Okay, and so 123 mod 7 is going to equal 4. We'll add the two of those together, 3 plus 4, okay, and then we'll find that mod 7. So that equals 7 mod 7, which equals 0. So our answer is 0. Weird. I just find number theory stuff. Sometimes you're like, what? I just added two numbers that are nowhere near 0 and I ended up at 0. And you're like, yep, that's number theory. All right, let's multiply them together. So now we take 3 times 4. So if we take 423, okay, times, and this is in modulo 7, 123, okay, that's going to equal 3 times 4 modulo 7, which equals 12 mod 7, which equals 5. Okay, and that's because 12 equals 7 times 1